So, after our discussion on diode approximation or modeling of diode characteristics with its approximation as ideal diode model, then constant voltage drop model, and finally piecewise linear model, which is closer to the actual characteristics or practical characteristics of a diode there. Now, after considering those diode models which were for analyzing an electrical circuit in an easier way or quick analysis of any electrical circuit, we were using those approximate models there, and in that mostly one example was taken on constant voltage drop model. So, I will quickly brief on that, which will be again used today for further analysis of the circuitry which are planned for this session. In this session, we will be basically analyzing the circuits which involves resistive electrical element and diode, the way we were considering in the earlier discussion. Then later we will be going with another electrical component like capacitors with it, but not for this lecture. So, before going to that discussion, today's lecture will be mostly on resistive electrical element and along with its diode. But with an example of clipper circuits, we were discussing the electrical circuits there. Now, we will be going for shunt clipping circuits, series shunt clippers. So, previously a constant voltage drop model of diode we have already used, which was in this fashion we considered, where this is the Vf voltage for which the current was found immediately flowing through the diode, and less than Vf voltage, which is again forward biased voltage named as VDF. Even though it is forward biased voltage, still diode could not conduct because it is not reaching to the voltage drop Vf, which is a constant voltage drop, which we want first to apply across the diode so that diodes start conducting. So, after we reach there, now this significance of this vertical line is that the current we want to draw through the circuitry where diode is involved there, in that without changing voltage across the diode, current goes whatever value we want from it. So, here an incremental point which I will ask you to always remember, that here the current after we reach the voltage Vf, the current whatever we like to draw, we will draw, but the voltage across the diode will not change, but it will remain constant at this Vf voltage. Please always remember this point before we proceed for the further discussion. So, earlier we considered clipping circuits, but with series connection. There we have considered this shunt configuration. What do you mean by shunt? Basically, shunt means it is shunted with the load. That means diode is shunted with load, or the diode connected parallel to the load resistor. Which way? Typically, say one electrical circuit R1 is there, in that one load RL is connected to it, and across it one diode is connected there this way. So, this diode is D1 is named. Since the diode is connected parallel to the load, we will call this configuration as shunt configuration. And since it is working as a clipper, we will be calling it as shunt clipper circuit. Okay. So, in this, if some voltage Vi is applied here, we will get some output voltage, say V0. That we want to see if a voltage waveform Vi is applied to the input to this circuitry, how it gets clipped at the output side. The way we were considering in the earlier classes for earlier lecture for series clipping circuit. Now let's say we analyze an input voltage and its output after it passed through the circuitry which is given here. So, say I am applying one voltage Vi, where reference is kept at 0 volt. So, if I apply this voltage to the input, then if it is going up to plus E and minus E at the negative side, with respect to some potential, it is going up to E or up to minus E with respect to whom? With respect to this 0 volt. Okay. So, if it is 0 there and that input signal we want to apply to this circuitry, so somewhere some reference point should be kept first. So, let us keep the reference here, which is a 0 volt, means grounded with 0 potential. So, if we apply this voltage here the voltage will go sometime plus E and sometime minus E depending on this wave shape. Fine. Now, if we want to see the output across it, let us draw in proper scale. Where reference is kept first as 0 volt, with respect to which the output is to be plotted here as V0. Now, if I consider here the 0 volt is applied before this, will this diode conduct? Not at all. So, here the voltage I get here, obviously this should be 0. Now, immediately after this, if the voltage goes to plus E, which is much more than the potential Vf which is defined for that diode and its constant voltage drop, after which the current will start flowing. Say this voltage is that high. So, what happens to this circuitry when it achieves this plus E volt? In that case, I will consider that if total voltage come across it, is it more than Ef or not? The time I find that it is more than Ef, that means current will start flowing there. So, what happens to the diode then? If the diode equivalent circuit is drawn depending on this model, so I can modify this block this way, where diode was up to this with constant voltage drop model. Fine. Now, if I ask you, if this is the configuration at this stage where E voltage is applied at the input, what should be the output? If this is the voltage applied across this load which has gone as output V0, that means if I know the current through RL and value of RL, then I can say how much voltage it is. But why should I know RL and also current through it if I know VF value? Because diode what I have considered, I know that VF value. If this is VF, what is the potential here with respect to this ground 0? Obviously VF. So, no need to go for this further analysis. Directly you consider that the output voltage should be VF only, because it is shunted to the load. So, for this particular range, I will get a voltage which will be Vf fine. Now, the time I reach this point, suddenly it goes to the wave shape at the input to the negative E volt. The time I reach to this voltage, what happens to the circuitry? Where the diode was kept earlier here in this fashion, now it has got one negative volt E. That means here minus, here plus, amplitude is E, but the polarity has got changed there. So, negative N side has got the positive potential and P side has got negative potential. So, it is open. It is like you are in this side. So, diode will be not conducting, or current through the diode is 0, or as if diode connection is not at all there, which is open circuited. If it is so, now what is the output voltage? As if no diode is there. So, the output voltage what I get for this part, what should be this amplitude? V naught should be equals to this voltage which is flowing here, voltage here, current is flowing through this, VE by R1 plus RL into RL, E by R1 plus RL into RL. What is the polarity? Obviously negative, because you are applying not plus E but minus E. That is why you are getting this negative voltage here. Again, if it repeats, then you will be getting the other shape. Okay. Now, since this particular arrangement has clipped the positive part of this wave shape, you will be calling this as positive shunt clipper. Means it is clipping of the positive part. Fine. Let us move for the negative clipping circuit. Any doubt, anything? Now, I will ask you, please draw the circuit diagram for negative clipper, negative shunt clipper. Circuit is exactly same, only the other way things should work. So, I will revert the diode. What is the voltage I will consider here? Vf if it conducts. If it does not conduct, then this is open. Same consideration of this diode model if I consider and try to find the output wave shape for a particular wave shape what we considered earlier. Please draw the output wave shape. I think I will just incremental concept I will apply there, where if positive voltage has come there. In that case, positive potential has come here, plus E has gone to the negative side, N side, and minus E has gone to the, or negative potential has gone to the P side. So it is open circuited at the beginning. So what should be the output? Just other way we were getting there. So for positive side, I will have the wave shape as I want it. Maybe the output voltage, which will be E by R1 plus RL into RL, which is not exactly E, but the wave shape what I wanted, that wave shape for the positive side, it is there. What is about the other side? VF, positive here, negative here. If it conducts, in that case, the voltage here which comes as V0, what will be that? Plus VF or minus VF? Obviously minus VF. Okay. Now, if I quickly ask you to extend this constant voltage drop model to ideal model, what happens? VF will become 0. So in that case, no need to consider this part. Directly I will be going here. But main theme is that negative part is clipped off. So it will be called negative clipper. Whatever diode model you want, you can take there. If I extend it for piecewise linear model, in that case, I will not consider only VF. Along with that, one small resistor RD I will be taking there. Depending on the voltage, how much I have applied, for which the linearity is maintained through this RD value. Okay. So for that, the modification in the voltage value which will happen there, that to be checked. Okay. But the complexity there is that you need to know how much current is flowing to the diode, which we don't need for constant voltage drop model or ideal model. Because in that case, to know the potential across this RL, which is shunted to the diode, which is this potential plus ID into RD. So VF plus ID into RD is the output voltage in that case. So this much modification is to be made, but it can be easily extended to that. Okay. So this way we discussed about positive and negative clippers. Then, as like earlier discussion on series clippers, let's go for removing noise part by using shunt clippers or noise clippers. So one input is given to you of this shape, where it was supposed to be constant at this level, but it is rippling in between with a highest value of something and lowest value of something there. You want to clip off this noise part from here, or this noise part from there, where you will be using diode as clipper circuit element. Okay. So, for that you take the same arrangement like earlier, say one resistance R1 is connected and then one diode D1 is connected this way and another diode which is connected other way to it. Now, please draw the output wave shape. What should be the output voltage? Either way, plus or minus? If I analyze from the beginning, like say, if the voltage has gone positive, then since the arrangement of the diodes are made in this fashion, one will conduct, another will not. If one conducts there, then Vf voltage we will get across it. So, say for positive side, if this diode is conducting, I will be getting plus minus Vf here. What is about the other? Nothing is there, so it is just open. So, tell me the output voltage. Obviously, it is plus Vf. Similarly, I can revert the other way. I will make one open and other with negative here, no, negative here, positive here. I think this way the diode was connected, P side in other way, but the potential is again Vf. But with respect to ground, if you see this is the reference point which is 0 volt there. With respect to this, this one is Vf volt that I found from here, but it is a negative voltage. So, I will get a negative Vf there. Anything? What is that? Low resistance of RL if you want to connect. She is saying that if RL resistance load is connected across it, what happens to this? We can modify it accordingly. So this discussion is complete now without RL. Now here I will say RL what I have connected, that is infinity. That's why it is open. But if you want finite RL there, you please put that RL there. If RL is connected there, what is about the output voltage? It hardly matters, because the voltage across this two terminal, that is fully decided by the diode potential here. Now parallel to this, if you are connecting another circuit element, it hardly bother. Now actually one question may be in her mind, that's why she is not leaving it so easily. And that is nice question. Like how it is possible? One device is one element is connected, the electrical element, I will not say device right now. One element is connected there, which is electrical element parallel to another electrical element, but it is controlling its voltage across it. This is the beauty of this circuit element, which is called diode there, or PN junction diode, which has the characteristics like this in this, as per this constant voltage drop model. It will drive the current whatever it likes, keeping the voltage constant to this voltage without depending to other elements which are connected across it. This could be done by the system because it is a non-linear system and it is a special electronic device which has that characteristics. So, it is so popular. Okay. So, for that only, since and because of these characteristics only, this kind of circuit analysis is in this discussion. These are the special characteristics of the electronic device diode, which will not allow to change the voltage across this terminal. Yes. If it is ideal, another good question. He is asking, if we consider ideal diode model, what happens to this circuitry? In this circuit, I will get the output voltage 0 because it is short, no concept of VF, because diodes start flowing at this point only. So, the voltage potential across this will be 0. This is quite obvious. Actually, I wanted to come to that discussion, that if the connection is like this, which is dependent by that voltage VF, then the output voltage is VF. But is it always possible to accept this kind of circuitry where I am going to remove the noise from here, where this voltage may go up to 10 volt and VF may be 0.3 or 0.7 volt. So, actual sense is gone. Only thing you could do, you could remove the rippling there, which was supposed to be a constant level here, you are getting the constant level there. But answer is there for you in the next discussion, where we can put another bias to it so that the actual voltage it reaches, but noise will be again clipped off. Question is coming there, answer is coming for you. But in this case, since you have asked this question, if it is ideal diode model, what happens to the actual circuitry? I am concerned about the matter which is much more practical. In that case, if this R1 would not be connected to the circuitry, say this R1 is equals to 0, means you didn't connect any R1, but directly you have short the circuitry. Only diode was connected here. In that case, current would flow infinite. Through which? Through the diode which was connected to it. So, in that case, this diode could be burned. That is why the circuitry what we are considering here, which is always involving R1 non-zero value, so that we will have a maximum limit of current flow even though diode is short circuited or considered, or the voltage across the diode tends to 0. Just like, for example, if I am considering 0.7 volt or 0.3 volt, if I consider 10 volt or 15 volt, which is very natural for our electronic devices to operate with. So, compared to 15 volt, I can consider 0.3 or 0.7 volt is negligibly small and tends to 0. In that case, current can flow very high, so that can burn the diode. So, for that safety purpose, always we need one R1 to 8. If you have opened your small electrical circuits like where LEDs are involved, LEDs are used for glowing. With one resistor, it is with one battery, it is connected there. If you directly connect the LED, it can burn any time. But if you see the actual circuitry where LEDs are used, you will see one series resistance is always connected to that one. That series resistance is decided with respect to the current handling capability or power handling capability of the diode. That means maximum current that can be allowed through the diode. Depending on that, this resistance R1 in series to the diode will be decided, so that even though diode is at 0 volt, still the current flows through it in a controlled manner, it is there. Okay. So, that is why in this circuitry also we are always considering R1 non-zero. Okay. Now, let us come to his question, what he has asked about, if it is not VF, but at a certain voltage level, I want the flatness, not at VF, because if VF, one diode is given there, VF is defined for it. Just like for silicon diode, the VF will be this 0.7, or for germanium diode, the VF will be say 0.3 volt in general. But we are not satisfied with that, but with a particular voltage we want this clipping action. So let's put one biasing to that circuitry. We will discuss rigorously on that circuit. Please come. Purposefully, I have take this circuitry in this form. Because I want that small incremental learning in this notation also, where this dot, if it is given there, it is an electrical connection, not bypass. If it would be bypass, then wires would come this way. This is a bypass. Okay, but here if I put the dot, that means these are connected. So let me explain the configuration. Here one resistance R1 is connected to two diodes, where these diodes are connected with another potential VB1 in the other side, and this is connected to the other potential VB2. If I say VB1 and VB2, that means this is a potential with respect to somebody. What is the reference point? Reference point is this one, means this line. If I find this V0, then always I will try one reference first with respect to which I will be measuring the voltage V0. Fine. Now, in this stage at the very beginning, if I want to tackle this kind of problem, I may like to simplify the circuitry so that it will be much more convenient for me to look into it. So I will ask you to see the circuitry in another way, more realistic. If they say some voltage is connected, potential is given here, say it is plus 2 volt, and here it is minus 2 volt. Say, for example, VV1 is potential, na? So if it is plus 2 volt, how it will look? Just like one battery is connected there of 2 volt. So I am connecting one battery there like this, plus minus 2 volt. Now 2 volt with respect to whom? Obviously with respect to 0. What is this 0? Where from I got? It is again this point only. If I have put this to the ground, this point also I have to put to the ground. Just like your pencil batteries, what you see there. The positive side is connected here and the negative side has gone to the ground, nothing else. Or to this wire. It is not necessary that always you will say that I have not connected that to the ground, but actually you have connected to the common point. It is not necessary that always you have to connect to the ground, because ground is 0, that's why we consider 0, but you can measure the potential with respect to any voltage. If you measure 2 volt with respect to 1 volt, then it is a 1 volt effectively, this much. Okay, so for that reference only it is considered. Now, if I ask you here, what modification you will make? Here you will connect one battery where negative side will be given there and positive side will be here, and other side should go to the ground. So positive here, negative here. Since it is in other way, means this point or this point which is at negative voltage with respect to ground, I had to put the battery this way. Fine. Now again I will redraw this circuit, which will be much more easier for me at least to analyze. Say I will take this part first. That D1 diode I will consider in this fashion, where I am saying this P side is connected to this point. Here I have again put P side there to that point of this diode, and negative side has gone to positive potential 2 volt. So I am putting positive here with 2 volt, which is named as VB1, and negative side has gone to ground, which is very close to me. So I am connecting it directly. It is fine. I have not disturbed the circuitry or configuration. Exactly whatever it is, I am just redrawing it. Okay. Now this part again in the same fashion I will be extending. So this negative side is connected to this point of the diode D2. Negative potential is there available, minus 2 volt, which is named as VB2, and positive side has gone to the ground. Okay. Fine. Now if I ask you some potential I have applied as VI there, I have to find out the V0 at the outside, which I was asking you here in this configuration. Okay. So the idea what we were having earlier, let's say consider the constant voltage drop model here again to analyze. Let's say the input waveform is given of this shape, or highest is plus E, this part is minus E volt with respect to this 0, and this is Vi and this is V0. With respect to 0 volt, I would like to get the output voltage. How different it is from your earlier circuitry where we have considered it as noise cancellation or noise clipper? Exactly same, other than this 2 extra thing which is there. Remaining things are exactly same. Which way they are different? They are externally biased with a potential. As I said you there that I want one external thing to incorporate in it. This kind of external thing I have incorporated as VV1 and VV2. Now after I could draw it in this fashion, remaining thing are simply circuit analysis. Fine. Let's move for the positive side to analyze. If a positive voltage is coming here, that means plus here, minus here. So that potential, if it would go directly to the diodes, what would happen to it? First of all, this diode would be open circuited. Remove it. What happens to this diode with constant voltage drop model? I will replace it with VF potential. After I find that this VI, the voltage which is going here, gone above VF, then this diode will start conducting. Small error will be there, forget it. Yes, in last previous class, few people were asking, is there any discontinuity? Yes, there is some discontinuity because of that VF. But discontinuity can be removed if you consider VF equals to 0. Okay. So if it goes beyond VF, so you will equivalently represent this as one ideal diode which is short, and then what should be the potential? Plus here, minus here, because P was up and N side was down. plus minus Vf. Okay. Now, if I ask you what is the output voltage then? I connect RL or don't connect RL, it doesn't matter. It will be Vf plus Vb1. What is the maximum voltage here? Vf plus Vb1. Is not it? So, if this is 2 volt and Vf is 0.7, what should be the exact value here? 2.7. Say Vf is equals to 0.7 volt. But earlier it was only 0.7. Now, if you want in place of 2.7, if you want 10.7, that hardly matters to you. In place of 2 volt, Vb1 will be considered 10 volt. Okay. Similarly, if I go other side, then I can also make the other arrangement. What should be the value there with respect to Vb2? What will be the polarity? Obviously minus. Okay. So, if these voltages are there to bias the circuitry, means Vb1 and Vb2, that is everything in my reach. Like, if I want clipping a positive side more and negative side less, then I will accordingly put V1 and Vb1 and Vb2. That doesn't matter. In positive side I will be clipping or negative side I will be clipping. If I want clipping at the positive side, I will be considering Vb1, or in the negative side I will be considering Vb2. So, this way these two are different, where if with respect to the earlier circuitry where we considered this clipping, where maybe this was at 10 volt. So, I want this level which is at 10 volt in which some rippling was happening. So, how much value I will take? If Vf is considered 0.7, I will be considering 9.3 volt. My purpose is served. Okay. So, this way you will be developing the circuitry depending on your requirement. But only thing I will like you to convey here, that things what we started in this discussion, purely a ground level discussion what we started with, and now with the discussion which we are finishing this session is a complete analysis of one diode circuitry there. Maybe it is an example for clipping, or I can extend this with a name like half wave rectifier. Or HWR. Many of you have already, I think, come across with this discussion where we wanted to clip off one cycle or half of the cycle and allowed the remaining cycle which was coming this way. And for full wave rectifier, where we wanted full wave portion, in that case, along with one arrangement for half wave rectifier, I will be just enhancing the circuitry so that negative part also of the wave shape come into picture and it lies along with this one. So, our full wave rectifier is there with us. Now, if full wave rectifier output is available with me like this, which is supposed to be a DC value. Generally, for DC, to obtain one DC value from AC source, we use the rectifiers, where we will be getting direct current which will be not alternating its polarity with respect to a particular level. That is why it is called direct. It is going in a direct, in a direct path, not altering its path there. So, we will call direct current voltage. So, in that, with respect to this 0, some voltage level will come there. If I say that this rippling is too low, so I consider the output this way, and it is so low that I have clipped off the small rippling and I got a parallel line here like the clipped voltage I got here. So, this kind of small rippling what we wanted to consider there, that those were big to accept this kind of arrangement or devise this kind of arrangement there to obtain a flat line, which is much more desired for our electronic circuit to give supply as DC. We connect our computers and all which are digital circuits which needs only DC, not AC, but it operates with the AC. So, at the very beginning this kind of circuitry come into picture where clipping of those things should be done at the beginning, where noise also should be clipped off at the very beginning. So, this way the clipping can be done by different way. I will give you one more example in this direction with a Zener diode where this clipping, which is supposed to be a much more stable one compared to this circuitry. After I have analyzed so many things on clipper circuits, now here same thing is involved here, same kind of discussion can be made here, but the things are only different here in terms of the diode which is used. So, I would like few words to spend on this diode which I have considered here for some particular purpose. Actually, compared to our general diodes, this general diode has one special characteristics like this, where this breakdown which happens there at the diode current conduction, that is allowed for Zener diode, which is not for the general diodes. General diodes may not control may not bear the current which flows huge in the breakdown voltage, but Zener diodes are made for that. It will able to handle those huge current there. It is specially made. That is why the symbol wise also Zener diode is made different there. Not only that, it is also important here because at the knee voltage, suddenly with a small fraction of voltage variation, the current will be going too high, which cannot be obtained for the general diodes. So, that way if it is so, if with a small variation of it compared to other diodes, it is possible for us to draw the current there, then I can expect much more fixed voltage at this breakdown compared to other, particularly for forward characteristics of the diode. If you consider, it does not go like this sharp, it always has a particular way of going where the current does not increase so rapidly, which Zener diode can do. But only thing is that it works in the reverse direction. So, the discussions what we have made there, that only change here is that when you are considering about the conduction of the diodes here, you have to consider that whether the Zener diode has got reverse breakdown or not. So, what is about the forward then? That ideal constant voltage drop model, if I use, some VF exists there, it is quite obvious. Say if some potential voltage is applied, positive voltage is applied at the input, say plus 5 volt. What happens to the circuitry? The voltage this diode gets, that is forward biased, because it is positive, it is negative. So, I will be making it what voltage? Huh? Yes, VF. What voltage I will make here? It is reverse biased. It has got breakdown, where Vz 5 volt is much more than the Vz, means this breakdown voltage. So, it has gone breakdown. So, the voltage will be Vz. Please look into it. What is the polarity of the potential? It is plus here, minus here. So, it is positive Vz. You have to apply this positive Vz. Otherwise, this diode is not in breakdown condition. But this does not bother for us. Only thing bothers to us is what is the output voltage finally. How much it is? Vf plus Vz. Now, if you name this diode D1 and D2 and the breakdown voltage Vz2,